Creo Parametric 10.0, generative design has been enhanced to support the ability to define a force load through a point and apply it to preserved geometry surfaces in your study. This will represent a distributed load that is statistically equivalent to a load applied to a single remote point. In this example, we'll access generative design and add a new total load at point force with a defined value and apply it to the top surface of the preserved geometry. Selecting the force load icon in the physics group, you'll change the distributed type from total force to total load at point in the force load dialog. This dialog will update to include the ability to select a defined point. To define the load, select the surface references of the preserved geometry for the load to be distributed on. In this case, the top surface of the ring. Now select the point where the load will be defined and enter the value for the point load. There are two types of behaviors for a total load at point force: deformable and rigid. The deformable behavior will allow the connected bodies to deform by not adding stiffness to the system, whereas the rigid behavior will not allow the connected bodies to deform by adding stiffness. For the optimization, we'll choose deformed, which is the default. Once completed, you can run the optimization. As the optimization is processing, you'll notice a shape start to materialize, leveraging the force load through a point based on the design goals. Once finished, the optimized shape can easily be reconstructed to produce a rich B-rep model for downstream use. This enhancement will allow you to easily apply a distributed point force over selected references the load is applied to. You can now capture your design intent without compromising the loading conditions.